Greetings to every one of you. In this video, we are going to discuss k-means clustering algorithm from machine learning. It is a popular computerized, unsupervised machine learning algorithm used for partitioning a data set into a predefined number of clusters. Clusters are nothing but groups. The main goal is to group similar data points together and discover the underlying patterns or structures within the given set of data. We used to minimize the distance between the points within a cluster. We can have so many examples like online customer behavior, medical diagnosis. All these are some of the applications where we can use k-means clustering. Let us see the algorithm, the various steps. First one, decide or choose how many number of clusters you are going to have. Number two, randomly assign a centroid to each of the clusters. If you have two clusters and you have to assign two centroid values. Calculate the equivalent distance of all observation to each of this k centroid. So the observed value and the centroid value can be used to find out the distance. So here the formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. This x2, y2, they are observed values, and this x1 and y1 are the centroid values. Step number 4, assign the observation to the closest centroid. So after calculating the distance, depends upon the value of the distance, you have to take the point, that is move the point to that particular cluster, the nearest one. Fifth step, find the new location of each centroid by calculating the mean of observed value with the centroid value. Once at the point, move to the particular cluster and there you have to update the centroid value. That is updation of centroids. Finally, repeat this step 3 to 5 until the centroid do not change the position or till the end of the data points. These are the steps of the algorithm. Now let us see how this algorithm work, that we can see with the help of an example. Let us consider we have data points, customers, number, age and quantity of purchase. So different customers, they are purchasing the different amount of quantity, but again that may depends upon the age. So here it is, all these data points are plotted in the form of a graph in which the age in x-axis and the quantity of purchase, it is in y-axis. The data points are plotted here. Now let us see how this algorithm works. Now we consider we have two clusters, cluster that is k1 and another cluster that is k2. And initially you have to assign the centroid values. Let us consider we assign the centroid value for this cluster 1 as this S1. So S1 value, it is 25, 100. Similarly for K2 we assign this S2 value. It is 30, 300. So these are the centroids. Now we have to, that is, calculate the distance for the observed value. So these are the centroids, and now we have to calculate the distance for this observed value. So what is this? This S3 is our observed value, and we have to substitute this in the formula, that is square root of. So the value of x2, it is nothing but 40 minus, here this x1, it is 25 whole square, plus, and next one is, that is 400, this is 400 minus 300 whole square. Find out the value. So the value will be, that is approximately, it is equal to, that is 337. Similarly for this is for K1. Similarly for K2, S3, calculate the value. Now you have to use these values, okay? For the same points, you have to use these points, that is centroids. It is 40 minus 30 whole square plus 400 minus, this is 300. But previously it should be, that is 100, sorry. It should be, that is 100. So the answer is, there is 300 here, square. So this is equal to, this value is, it is equal to 100.49. Okay. So now just you compare these two values, which is closer. Cluster K2 has the smaller value. So what you have to do? You have to, that is update this K2 value. So if you say, that is actually the K1 contain this S1, and K2 contain this S2. Our next value, it is, what is that? It is the S3. So S3 is, what is that? S3, it is more closer to only this cluster K2. So now you can add this value, that is S3 here. Okay. Now you have to, that is update this cluster, I mean centroid values of this S2. This must be, that is updated. So with the help of, what's that? This new observed value. So what is the observation value? It is 40 plus 30 divided by 2. It is 70 by 2. So we have 35. So this new value, it is 35. And similarly, this is 300, this is 400. 300 plus 400 divided by 2, it is nothing but 350. So this is the new centroid value. This is 350. Is it clear? So now we got the new centroid values. That is the data point S3. It is very closer to K2. That is what actually we have found out now. Now we have to proceed for the next data point. What is the next data point? It is S4. So S4, it is 19 and 200. These are the observed values. So now substitute for K1. For K1, it is X2, it is 19 minus 25 whole square plus, it is 200 minus 100 whole square. So the value or the answer for this one, it is 100.17. So similarly for K2, it is 19 minus 35 whole square plus, this is 200 minus 350 whole square, which is equal to that is it is 150.85. So now just 100, it is a lesser value. So K1, this S4 will move to this cluster K1. Okay, so S4 move to cluster K1. Okay, So now we have to calculate this new centroid value for this K1. How to calculate the new centroid value? With the help of this value, that is 25 plus 19 divided by 2. So this it is nothing but 22. Okay. So the next one is that is 200 plus this 100 by 2, it is nothing but 150. So now our centroid values of this K1, it is 22 and 150. So the next data point is S5, which contain the values 36 and 500. In order to find out the distance for K1, square root of it is 36 minus 22 whole square plus 500 minus 150 whole square. So for this the value it is 350.27. Similarly for K2, square root of the value, that is 36 minus 35 square whole square plus this is 500 minus this is 350 whole square. This value it is equal to 150. Okay. So which is lesser one? So 150 is lesser. So automatically that means the point, this S5, it belongs to the cluster K2. Okay. It belongs to cluster K2, that is S point number S5, data point S5. So now what you have to do? You have to calculate this new centroid, because since it belongs to K2, we got the new point get added in cluster K2. We have to update the centroid of K2. The new value is 36,500. So 36 plus 35 divided by 2, it is nothing but 35.5. Similarly, this is 500 plus 350 divided by 2. So 850 divided by 2 is nothing but 425. So now update the value, it is 35.5 and this is 425. Now we have to proceed for the next data point, that is S6. So X6 values are 42 and 475. Again, in order to find out the distance, Euclidean distance, substitute the values. This is 42 minus 22 whole square plus this is 475 minus 150 whole square. Find out the value. The value it is 325.61. Similarly for K2, again apply the same formula. This is 42 for the cluster K2, it is 35.5 whole square plus this is 475 minus this is 425 whole square, which is equal to, it is 50.42. So the value, the lesser value, it is 50.42. So automatically this particular point, that is S6, belongs to cluster K2. Okay. So now add it in cluster, that is K2. Right. So no more data points available there, so we can stop the process. Or if you have any more points, we have to continue the same procedure till the centroid values won't get changed. Okay, if there is no change in the centroid values, there we can stop. So as a result, we are able to, that is, identify, see this cluster K1 contain this S1 and S4. What is this S1 and S4? You see here. So we have the values here. This is one cluster, and remaining all other values, that is, you see that all these 4 points comes under another cluster. Okay, so this is K1 and this is K2. So very well you can see that the age of the customer S1 and S4, they are less, and the age of the customers, that is S2, S3, S5, S6 are greater. I hope you are able to understand the concepts. So in this video I explain what is k-means clustering and explain the algorithm, and with the help of this example I explain. I hope you understood. Keep watching. Thank you.